NENOMATICA, where mathematics meets YouTube excellence. The fourth law of power. Welcome to our video on exponent rules. Today we're going to learn about the division of powers with the same exponent. The rule we're going to explore today states that when we divide powers with the same base, we can simplify this by dividing the bases and keeping the same exponent. Specifically, a to the power of m divided by b to the power of m equals the fraction a over b, all raised to the power of m. Let's prove this rule step by step so we understand why it works. We'll consider any real numbers a and b and any integer m. Step 1. Let's start with the left side of our equation. When we divide a to the m by b to the m, we can write this as a fraction with a to the m in the numerator and b to the m in the denominator. Step 2. Now let's expand both the numerator and denominator by writing out what these exponents mean. A to the m means a multiplied by itself m times. Similarly, b to the m means b multiplied by itself m times. Step 3. Now we can rewrite this fraction as a product of fractions. We pair each a in the numerator with a corresponding b in the denominator, creating m fractions of a over b. Step 4. Now we have the fraction a over b repeated m times as a product. This is exactly the definition of raising a over b to the power of m. So we've proven that a to the m divided by b to the m equals a over b raised to the power of m. This is a powerful rule that allows us to simplify complex divisions involving exponents. Let's look at an example to see this rule in action. Consider 25 to the fourth power divided by 5 to the fourth power. Using our rule, we can rewrite this as the fraction 25 over 5, all raised to the fourth power. 25 divided by 5 is 5. So our answer is 5 to the fourth power, which equals 625. Let's try another example. What is 9 to the fourth power divided by 3 to the fourth power? Using our rule, this equals 9 over 3 raised to the fourth power. 9 divided by 3 equals 3, so we have 3 to the fourth power. 3 to the fourth power is 81. We need to compute 6 cubed divided by 2 cubed. In step 1, we recognize that we can use the division rule for powers with the same exponent. This rule states that a to the power n divided by b to the power n equals the fraction a over b, all raised to the power n. Applying this rule, we get the fraction 6 over 2, all raised to the power 3. In step 2, we simplify the fraction inside the parentheses. 6 divided by 2 equals 3, so we have 3 cubed. This equals 27. Let's move to our second example. We need to compute 2 to the power 7 divided by 1/3 to the power 7. In step 1, we apply the same division rule for powers. We get the fraction 2 over 1/3, all raised to the power 7. In step 2, we need to simplify the division by a fraction. Remember that dividing by a fraction is the same as multiplying by its reciprocal. So 2 divided by 1/3 equals 2 times 3, which is 6. So our answer is 6 to the power 7. For our third example, we need to compute 9 to the power 6 divided by 3 to the power 6. In step 1, we apply the division rule for powers again. We get 9 over 3, all raised to the power 6. In step 2, we simplify the fraction. 9 divided by 3 equals 3, so the answer is 3 to the power 6, which equals 729. For our final example, we need to compute 32 to the power 5 divided by 8 to the power 5. In step 1, we apply the division rule for powers. We get the fraction 32 over 8, all raised to the power 5. In step 2, we simplify the fraction. 32 divided by 8 equals 4. So our answer is 4 to the power 5, which equals 1024. Let's summarize what we've learned. When dividing powers with the same exponent, we can divide their bases and keep the exponent the same. This is expressed by the formula. A to the power n divided by b to the power n equals the fraction a over b, all raised to the power n. We've seen 4 examples of this rule. 6 cubed divided by 2 cubed equals 3 cubed. 2 to the 7th divided by 1/3 to the 7th equals 6 to the 7th. 9 to the 6th divided by 3 to the 6th equals 3 to the 6th. And 32 to the 5th divided by 8 to the 5th equals 4 to the 5th. Let's solve this example involving exponent division. Let's solve this step by step. In step 1, we'll rewrite the decimal as a fraction. 2.5 can be written as 5 halves. In step 2, let's apply the division rule of exponents. When dividing expressions with the same base, we can simply divide the bases and keep the exponent. However, here we need to first rewrite this expression. In step 3, we'll combine the fractions. When we have a fraction raised to a power, we can apply the exponent to both the numerator and denominator. For step 4, we'll multiply the fractions inside the parentheses. In step 5, we'll simplify the fraction inside the parentheses. And for our final answer, the power of 1/2 to the 7th is equal to 1 divided by 2 to the 7th power, or 1. We'll apply several exponent rules to simplify this expression step by step. First, let's rewrite 16 as 2 to the 4th power, since 16 equals 2 raised to the 4th power. This gives us 2 to the 4th power times a to the 4th power, all divided by 3 to the 4th power. Now, since both 2 and a have the same exponent, we can use the product to power rule. This rule states that x to the m times y to the m equals the product x times y, all raised to the power m. So 2 to the 4th times a to the 4th equals the product 2 times a, all raised to the 4th power. Next, we can apply the quotient to power rule. This rule states that x to the m divided by y to the m equals the quotient x divided by y, all raised to the power m. Applying this rule, we get 2 divided by 3, all raised to the 4th power, which is our final simplified answer. So our final simplified form of the expression 16a to the 4th power divided by 3 to the 4th power is the quantity 2 divided by 3, all raised to the 4th power. Let's move on to our second example, which is more complex. A to the 5th power times b cubed times a squared times b to the 4th power times a times b, all divided by the product a b cubed times ab to the 4th power. This expression looks complicated, but we can simplify it systematically. Our first step is to combine all the like terms in the numerator. For the terms, we add the exponents, a to the 5th plus a squared plus a to the 1st power, which gives us a to the 8th power. For the b terms, we add b cubed plus b to the 4th plus b to the 1st power, which gives us b to the 8th power. Now, let's simplify the denominator. We have ab to the 3rd power times ab to the 4th power. When we multiply these two terms, we add the exponents, giving us ab to the 7th power. Now we can rewrite our entire expression. We have a to the 8th power times b to the 8th power in the numerator, divided by ab to the 7th power in the denominator. Next, we can combine the terms in the numerator using the product to power rule again. A to the 8th times b to the 8th can be written as ab to the 8th power. Finally, we can apply the quotient of powers rule. When dividing the same base with different exponents, we subtract the exponents. So, ab to the 8th power divided by ab to the 7th power equals ab to the 8th minus 7th power, which equals ab to the 1st power, or simply ab. So our final simplified answer for the second example is simply ab. We have a to the 7th power divided by the product of a squared and b to the 5th power. First, let's rewrite this division as a single fraction. This gives us a to the 7th in the numerator, and a squared times b to the 5th power in the denominator. For step 2, let's use the exponent laws to break down the a to the 7th power in the numerator. We know that a to the 7th equals a squared times a to the 5th power. This gives us a fraction with a squared times a to the 5th power in the numerator, and a squared times b to the 5th power in the denominator. In step 3, we can simplify our fraction by canceling the common factor of a squared in both the numerator and denominator. When we do this, we're left with a to the 5th power in the numerator and b to the 5th power in the denominator. Finally, in step 4, we can express this as a single power by recognizing that a to the 5th power divided by b to the 5th power equals the fraction divided by b to the 5th power equals the fraction over b raised to the 5th power. So our final answer is a over b all raised to the 5th power. In this video, we'll learn how to simplify expressions with exponents and division. Let's solve this expression step by step. To solve this problem, we need to recall some exponent rules. The first rule we'll use states that when dividing terms with the same base, we subtract the exponents. That is, a to the power of m divided by a to the power of n equals a to the power of m minus n. Let's apply this rule to our expression. In the numerator, we have a to the power of 7 divided by a to the power of 4. Using our rule, this simplifies to a to the power of 7 minus 4, which equals a cubed. Similarly, in the denominator, we have b to the power of 5 divided by b to the power of 2. Applying the same rule, this simplifies to b to the power of 5 minus 2, which equals b cubed. Now, we can rewrite our original expression by substituting these simplified forms. We now have a cube divided by b cubed. Let's visualize what's happening here with a diagram. We start with the expression and apply our exponent rule to both the numerator and denominator. When we have the same expression with the same exponent in both numerator and denominator, we can write it as a fraction raised to that power. So, a cubed over b cubed becomes the fraction over b raised to the power of 3. Let's understand why this works. When we raise each term in a fraction to the same power, it's equivalent to raising the entire fraction to that power. In our case, we have a cubed in the numerator and b cubed in the denominator, which is the same as a over b, all cubed. This brings us to another important exponent rule, the quotient raised to a power rule. It states that the fraction over b, all raised to the power of n, equals a to the power of n over b to the power of n. To summarize the steps we took, first, we applied the division rule for exponents to simplify both the numerator and denominator. Then, we recognized that we had the same power in both numerator and denominator, allowing us to express the result as a single fraction raised to that power. So, our final answer is a over b, all cubed. And that's how we simplify this type of expression involving exponents and division. Remember the key rules we used. When dividing terms with the same base, subtract the exponents. And when we have the same exponent in both numerator and denominator, we can rewrite it as a fraction raised to that power. These fundamental rules will help you solve many different types of exponent problems. Let's see how we can use exponent properties to simplify complex expressions step by step. Let's start with our first example. We need to simplify the expression a to the power of 4 times b to the power of 4 times a to the power of 3 times b, all divided by b to the power of 7 times a squared times b squared times a. To simplify this expression, let's start with step 1, grouping like terms in both the numerator and denominator. We'll group the terms with base a together, and the terms with base b together. Step 2, now we'll apply the exponent property that states when multiplying powers with the same base, we add the exponents. So, a to the power of 4 times a to the power of 3 becomes a to the power of 7, and b to the power of 4 times b becomes b to the power of 5. Similarly, in the denominator, a squared times a becomes a cubed, and b to the power of 7 times b squared becomes b to the power of 9. Step 3. Let's rewrite this expression as a product of fractions, separating the terms with base a and the terms with base b. Step 4. Next, we'll apply another exponent property. When dividing powers with the same base, we subtract the exponents. So, a to the power of 7 divided by a cubed becomes a to the power of 4, and b to the power of 5 divided by b to the power of 9 becomes b to the power of negative 4. Step 5. Now let's express this with positive exponents only. Remember that a negative exponent means we move that factor to the opposite side of the fraction. So b to the power of negative 4 is equivalent to 1 divided by b to the power of 4. Step 6. Finally, we can write this as a single power, the fraction a over b raised to the power of 4. Therefore, our simplified expression is a over b all raised to the power of 4. Let's verify this. We started with a to the 4th times b to the 4th times a cubed times b all divided by b to the 7th times a squared times b squared times a. After simplifying, we get a over b all raised to the power of 4. Now, let's move on to our second example. We need to simplify the expression 12 to the power of 9 divided by the fraction 2 over 3 to the power of 9, all divided by 6 to the power of 9. Step 1. To simplify this expression, let's start by rewriting the division as multiplication by the reciprocal. So we have 12 to the power of 9 divided by the fraction 2 over 3 to the power of 9, all multiplied by 1 over 6 to the power of 9. Step 2. Now let's apply the exponent property for fractions. We know that a over b to the power of n equals a to the power of n over b to the power of n. And the reciprocal of a fraction to a power is the same as the reciprocal raised to that power. Step 3. Let's simplify the complex fraction. When dividing by a fraction, we multiply by its reciprocal. So, 12 divided by 2 over 3 is the same as 12 times 3 over 2, which equals 36 over 2, or 18. Step 4. Finally, we can apply the division property of exponents. 18 to the power of 9 divided by 6 to the power of 9 equals 18 over 6, all raised to the power of 9, which is 3 to the power of 9. Therefore, our simplified expression is 3 to the power of 9. We've successfully simplified the complex expression 12 to the power of 9, divided by the fraction 2 over 3 to the power of 9, all divided by 6 to the power of 9, to get 3 to the power of 9. In conclusion, we've learned how to simplify complex algebraic expressions involving exponents by applying these key properties. 1. When multiplying with the same base, add the exponents. 2. When dividing with the same base, subtract the exponents. 3. A negative exponent means we move that factor to the opposite side of the fraction. For fractions with exponents, we apply the exponent to both numerator and denominator. By applying these properties step by step, we can simplify even the most complicated expressions. Our first example involves simplifying a fraction with various exponents. We have a fraction with a to the 7 times b to the 4 times a to the 3 times b to the 6 in the numerator, and in the denominator we have the quantity a times b quantity squared times the quantity a times b to the 8th power. Let's begin by using the laws of exponents. When multiplying terms with the same base, we add their exponents. So let's combine the a terms and b terms in the numerator. We'll add their respective exponents. Next, let's work on the denominator. We have the product of a times b raised to different powers. When multiplying expressions with the same base, we add the exponents. So we'll add 2 plus 8 to get 10. Now, let's expand the denominator. When we have a product raised to a power, we can distribute the exponent to each factor. So, a times b raised to the 10th power becomes a to the 10th times b to the 10th. Finally, we can see that the numerator and denominator are identical. Any non-zero expression divided by itself equals 1. So our answer simplifies to just 1. Now, let's move on to our second example, which is a bit more complex. Our second example involves simplifying a more complex fraction. In the numerator, we have a to the 1,375 divided by a to the 74, and that quantity is multiplied by a to the 99. In the denominator, we have b to the 200 times b to the 500 times b to the 700. Let's start with the numerator. When dividing terms with the same base, we subtract exponents. So a to the 1,375 divided by a to the 74 becomes a to the power of 1,375 minus 74, which is 1,301. Next, let's combine like terms in both the numerator and denominator. In the numerator, we add exponents when multiplying terms with the same base. So a to the 1,301 times a to the 99 gives us a to the 1,400. Similarly, in the denominator, we add the exponents of b, 200 plus 500 plus 700, which equals 1,400. Finally, we can write this as a single power. The fraction a to the power n divided by b to the power n can be written as the ratio a over b, all raised to the power n. So, a to the 1400 over b to the 1400 becomes a over b, all raised to the 1400 power. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.